This problem is a thermochemistry problem where they give us some information about a substance that's either being heated or cooled, and we need to remember the equation to determine how much heat, I guess, a particular substance can absorb or give off. As given here is Q, is the heat, is equal to the mass of that substance times the heat capacity of that substance, the specific heat capacity, which is, again, think of it as the amount of joules going into that substance to change 1 gram of it 1 degree Celsius, how much heat can be given to that substance. For example, water has a very high specific heat of 4.18 joules per gram per Celsius. So that's the specific heat capacity. Then delta T is, of course, the change in temperature. So they tell us that the substance here is 100 grams of aluminum, and it's initially at 145 degrees Celsius. We know it's at this temperature because then it says it gains this much heat. So intuitively, we're thinking, oh, it's going to heat up because it's gaining heat, this aluminum already at 145 degrees Celsius. And they say, what is the final temperature? So we know that when we find this change in temperature, we're going to have to add it to 145 to know what the final temperature is. So I think we're ready. They give us the heat capacity, the specific heat capacity of aluminum. And I don't have the units for this shown, but it's joules per gram per Celsius. So let's set this up. Our Q is given 6,800 or 6,800 joules is equal to, now they give us the mass, 100 grams of aluminum. I'll put the unit and what it is, aluminum. We times that by the specific heat capacity of our aluminum, and I'll go ahead and put the units in for that also. That's going to be joules per gram per Celsius, and then we're needing to find our change in temperature. Now for now, I'm just going to have that as our variable x that we're solving for. So of course now what we're going to do is isolate the x by dividing both sides by those variables we've already put in the numbers for. So I'm going to multiply these two together and then divide 6,800 by that. So let me go ahead and do that. I'll go ahead and take the 6,800. I'm just going to divide it by these individually. And then I'm going to divide it again by 0.897. Oops. So that's going to be 68 divided by, after we divide the 100 by 100 into this, I'll have 68. Then I'm going to divide that by the 0.897. That gives us x is equal to 75.8, we'll say 1 degrees Celsius, because we know as we took this over there, this unit's the only thing left. We've canceled our grams and the joules also canceled, so we have just Celsius left. So that's our temperature change, delta T. So we know we're looking for 145 plus 75. So I'm going to go ahead and hit plus that 145. So we're looking for an answer in the choices that they give us of 220.8 roughly degrees Celsius. And that's how we do a problem where we have been given how much heat has gone into a substance at a certain temperature, and they want us to know what the final temperature would be for that substance. Hope this helps. Bye-bye.